So students, center of mass of a system of particles, or you can say extended body, it moves as if all the mass of the system was concentrated at that point. So external force is actually assumed to be applied at this point. So acceleration of this point we are going to study. Okay, so but first of all we need to know how to calculate the center of mass. So this is very simple. Means it's a system of two particles, so we have two particles, mass m1 and m2. Okay, and see where is the position of these two masses. So these two masses are, we take these two masses on the line joining the two particles to be the x-axis. So both the masses lie on the x-axis. Now the center of mass of this system is at a distance x. So this at a distance, this is the center of mass. Okay, and it lies at distance x from the origin. So x1 is also the distance of m1 from the origin, x2 is also the distance of m2 from the origin, and capital X is the distance of center of mass from the origin. So this is the location. So we need to tell the location. So how will we tell it? So the formula that we have, x is equals to m1. So if you are taking m1, then its coordinate x1. Then m2, then multiply it with its coordinate x2. So m1 x1 plus m2 x2 divided by m1 plus m2. And if the masses are equal, so then this formula will reduce to x1 plus x2 divided by 2. So then thus the two particles, their center of mass will exactly lie midway between m1 and m2 if they are equal masses. And suppose if we have n number of masses, but all of them lie on the same, on the x-axis. This is what the condition that we have. So m3 and up to mn. So because we are finding x coordinate only of this system of particles. Okay, so similarly we can write the y coordinate also, sigma mi xi. So instead of xi, here I will have yi. Okay, so if they do not lie on the same line but they lie on the plane, then we have the coordinates for the y coordinates also, and that can simply be written as sigma mi. Okay, so but if all the mass lie on x-axis, definitely the center of mass will also lie on the x-axis. So we need to tell only the x coordinate. So the position, so the important thing is whenever the word comes center of mass, okay, find the center of mass of the system. Okay, like here it is written in this question, this example 7.1, find the center of mass. So find the center of mass means you need to tell the coordinates of the center of mass, means you need to tell the position of the center of mass. Okay, so if you look at this question, find the center of mass of the three particles at the vertices of equilateral triangle. The masses of the particles are 100 grams, 150 grams, 200 grams respectively. So here we have 100 grams, that is your m1. Here we have 150 gram, that is your m2, and here we have 200 gram, which is your m3. So now we have its xy plane, so we have two coordinates. So the coordinates of m1, we call it x1 y1, coordinates of m2 x2 y2, and coordinates of m3 x3 y3. And now first of all, so this is the formula that we have. The same formula, it was for two particles, it is for three particle system. So definitely we need the coordinate, and as there is y also, so we will have the formula for y, m1 y1 plus m2 y2 plus m3 y3 divided by the whole mass, means m1 plus m2 plus m3. So we need x1 x2 x3 and y1 y2 y3. Okay, so how do we find x1 y1 and x2 y2 and x3 y3? We know m1 m2 m3. So this is equilateral triangle and this is origin. So x1 y1 is the coordinates are 0 0, no problem with it. Now what are the coordinates of this point? So as this is equilateral triangle and the side is 0.5 meter, so this distance is 0.5 meters. So obviously the coordinates will be 0.5 and 0. So y-axis, y coordinate is 0 and x coordinate is 0.5 meter. Now what about the coordinates of this point? So in equilateral triangle, we have the, let us draw it here only. So in equilateral triangle, what is the height? So if this is side A or S, whatever you call it, so this will be A by 2, this length will be A by 2, and this length is A. So this length will be under the root A square minus A square by 4. Okay, and this comes out to be 4a square minus a square, 3a square by 4, and this comes out to be root 3 by 2a, right? This height. So because we want to find this coordinate, so root 3 by 2a. So, or you can say root 3a by 2. So a by 2 is 0.5 and then root 3. So this is this coordinate, y coordinate, and the x coordinates is the same. This x coordinate is half of the length, that is 0.5. So this is 0.5, this length a by, because this 0.5 centimeters, so half it is 0.25. So these are the coordinates, 0.25 and 0.25 root 3. So that's root 3 by 2a. So now it's so simple. We know the three coordinates and simply put the values and we get the center of mass, and we write the center of mass, the coordinates, with capital X and capital Y. Okay, now we have another question related to the center of mass. So we have a L-shaped lamina. So this L-shaped lamina, this is what we are talking about. This is lamina. Okay, and we have to find the center of mass. So lamina is nothing but it's a thin flat plate, and its dimensions are given to you. So this coordinate 0 0, this is 2 0, and this is 1. So this is 1, means this length is 1 and this total length is 2. So of course it is 1 1. And what about this? This 0 2 and this length is 1. So this is also 1 1, and this is also 1. This is also 1 and this is also 1. So all the lengths are, so it is clearly given 1 meters this height. So it means these are the three. We can divide this lamina in 3 squares. So the square of first is like this with the first one, the first square. So where will be the center of mass of this C1? So for this square, by symmetry, the center of mass will exactly lie at the midpoint. Okay, so where will be the midpoint? So C1 is 0 plus 1 by 2, that is 1 by 2, and 0 plus 1 by 2 is 1 by 2. So these are the coordinates, 1 by 2 and 1 by 2. And what are the coordinates of C2? This is 1 1 and this is 2 0. So 1 plus 2, that is 3 divided by 2, and 1 plus 0 is 1 divided by 2. So these are the coordinates of C2. And what are the coordinates of C3? So this is 0 plus 1, x coordinate. So 0 plus 1 is 1 divided by 2. So that's 1 by 2, and 2 plus 1. So adding the y coordinates, dividing them by 2. So 3 by 2. So now we know the coordinates and what are the masses. So total mass was 3 kg. So these squares, laminas, now we have their, so this mass 3 kg will be divided into 3 parts. So this is 1 kg, this also 1 kg, and this mass is also 1 kg. So we know the masses. All the 3 masses are in fact same. Okay. So simply using the formula, x is equals to m1 x1 m2 x2 plus m3 x3 divided by m1 plus m2 m3. So we get the x and y coordinate center of mass, and you know that it will lie on this line OD, because it is symmetrically dividing this L lamina in 2 parts. So we will have this xy center of mass coordinates along this line OD. Okay. So this was now we will do one exercise question based on this center of mass. Open your NCERT books, page 178. So that's the question that we have. So location of center of mass, sphere, cylinder, ring, cube, each of uniform mass density. So does the center of mass necessarily lie inside the body? So center of mass, it depends. Like I have discussed, it's a ring, or it's a, suppose, hollow hemisphere or hollow sphere. So, or so if it's a sphere, obviously center of mass will lie in it. If it's suppose hemisphere also, so center of mass will lie inside it. But if it's a, suppose, ring, so obviously center of mass will not lie on the ring, it will lie in the middle. So does the center of mass necessarily lie inside the body? No, it's not necessary. Okay. So center of mass may lie outside the body. So in case of, so you can see in case of if all of them are hollow, okay, so if sphere is hollow, if I have hollow sphere, for all the hollow bodies, the center of mass may lie outside body. Okay, so especially for hollow bodies, center of mass may lie outside the body. And students, we have formulas for center of mass for this means sphere. We know it at the center, cylinder, ring, cube. We know it is symmetrical, so at the center, ring also we can tell, and cylinder also. So actually at the geometric center they will lie. The center of mass will lie at the geometric center for these figures, for these 3D figures. Okay, now we have second question. So this is very simple question, like we did example 7.2. So in HCl molecule, the separation between the nuclei of the two atoms is this much, is the separation between them. So this is the x-axis. So only two particles are there. So and separation is given between them, so we can only take x-axis, and this is the molecule that you have. So take one at the origin. Okay, so you have HCl, right? So you can take H over here and Cl over here. Now can you calculate the center of mass of this particle? You only need the coordinates and the masses. So what are the coordinates of H? We are taking it as at the origin, so its coordinates are 0, 0. This point, so this point has coordinates 0, 0. And what about this point? What will be the coordinates of this point? So it is given that the separation between them is 1 angstrom, 1.27 angstrom. So this length will be on the x-axis 1.27 angstrom and 0. Y coordinate is 0. So we have only x coordinate. Okay. What about the masses? If mass of hydrogen you are taking, then you are taking it as x, then the mass of chlorine is 35.5 x. Okay, so the ratio is given to you. Now can you calculate it? So you can consider its mass as 1 unit, and you can consider this mass as 35.5 units. So x will be given by the position of the center of mass, will be given by the capital letter, and that is equals to m1 x1 plus m2 x2 divided by m1 plus m2. Yes. So 1 into 0, so need not to change into meters, because the answer will also come in angstrom. Okay, and as I told you that if you take it as x and if you take it as 35.5x, so x will be cancelled out. Okay, so this is 1 into what is x1 is 0 plus, so this is x1 y1, so x2 y2. So 1 into 0, and then what is the mass? 35.5 into x2 is 1.27 angstrom divided by 1 plus 35.5, and if you calculate it, you will find the answer 1.24 Armstrong. Okay, but we have assumed this as origin. It is not given to us. So we are measuring this x from this hydrogen. So it is at a distance of 1 point. So you can clearly see that the total is 1.27, and it is the center of mass is somewhere here. So this distance is 1.24 Armstrong. This is your center of mass, this position. So you can clearly see that it is not at the midpoint, but it is tilted towards chlorine because chlorine is more massive. So center of mass is actually the weighted average. Okay, so more is the, so center of mass will be on the side where it is where more mass is concentrated. Okay, so now we have third question. I read it from the book. So you have to write here. So 1.24 Armstrong from where? So 1.4 Armstrong from hydrogen end. Okay, this is what you need to write. Now a child sits 7.3 question. A child sits stationary at one end of a long trolley moving uniformly with speed v on a smooth horizontal floor. If the child gets up and run about on the trolley in any manner, then what is the effect of the speed of the center of mass of the student trolley system? Students, these kind of questions are very important, in fact. So there is one NCERT question last chapter also, that there is a trolley and a student is means a child is running, and then he jumped into the trolley. So as he jumped into the trolley, as he touched the trolley, there is a collision. Okay, and center of mass will be conserved in that case. Now once he is in the trolley, now he is part of the system. Now second case is, now he is running here and there. Of course this trolley is so now this is the trolley, and the child is running in this trolley. So when he is in the trolley and he is running, actually he is now the part of the system. Okay, and so as he is part of the system, so no external force. Here he was not the part of the system, so some force was applied when he jumped into the trolley. So there was collision, and in all the collisions, you know that momentum is conserved. Okay, but here after he is in the trolley now, so no external force. So if he is running or moving in the trolley, so no F external, so no external force is there. Okay, so no external force is there. So if no external force is there, then according to Newton's first law, so if no external forces, so, and even second law also, if F is equals to 0, A is equals to 0. A is equals to 0 means there is no change in velocity, so no change in speed. So if no external force, according to first law, there will be, the state of the body will not change. So the speed of center of mass, wherever it is, center of mass of system, remains unchanged. Okay, Why? Because no external force is acting on the body. So the forces that are involved in running, these are the forces applied due to running are the internal forces. So there will be no acceleration of center of mass. So, and velocity remains the constant, and acceleration of center of mass, we write it with capital letter. So that's 0. So acceleration is 0 of the center of mass. So that was our example numbers. Exercise question 7.3. Any doubts, students?
Sir, please repeat it again. समझ नहीं आता.
See, a boy is. This is a trolley which is moving in this direction, and the child, this boy is also running. Okay, and then he jumped into the trolley. Now he's in the trolley now. So when he jumped into the trolley, then it's a collision, and momentum will be conserved. Means Pi is equals to Pf. Okay, so there is a question related with this in the last chapter number 6. NCERT question is there. Okay, exercise question is there. Now this is our example 7.3. So it's not related with this. So 7.3 example has no connection with this. Don't get confused. Okay. So this thing has no connection. So I was just discussing with you that this is important case, that when the child jumped into the trolley, this is chapter number 6. Okay. But now in chapter number 7, we are only discussing that this child is running in the moving trolley. So this is moving trolley. So this is moving trolley. Okay. And the child is running here and there in this moving trolley. Okay. So if a child is running here and there in this moving trolley, is there any external force? No, the child and the trolley, they are part of the system. Okay, so now here the system is child plus trolley. So any force that the child is applying on the trolley is the internal force. You are sitting in the car, and if you start pushing the seat, will the car move? So that's the point. So sitting in the car, you have to come out of the car, and then you need to start pushing the car. Then only the car will move. So 4 people sitting in the car and start pushing the car. Will the car move?
No.
No. But when those 4 person will come out of the car and start pushing the car, will the car move? Yes.
Yes.
Yes, it may move. Okay. So that is why as the internal forces has no impact, we have studied earlier also. So the acceleration of the system can only be changed by the external force. Okay, because if a child is applying any force on the trolley, then trolley will also apply the equal and opposite force on the child. So internal forces cancelled out according to Newton's third law. Okay, so now as there is no external force applied on the system, so acceleration of the center of mass will be 0. So F external, you know that according to second law, F external is equals to m into a. So mass into acceleration. So if F external is 0, acceleration is 0. So the velocity of center of mass of the system will remain unchanged. Is it clear? Yes?
Yes, sir.
So example, exercise question, next exercise question 7.4. Show that area of triangle contained between the vectors A and B is 1/2 of the magnitude of A cross B. So what is the area? So I discussed it that with this vector A, and suppose this is vector B, and I am finding their cross product. So the resultant will, so if they are in the plane, if they are in XY plane, let me consider that they are in XY plane, so the resultant will be along the Z axis. Okay, so this is XY plane, the resultant, that is A cross B. So A cross B, this angle is theta, so this will be the resultant, it will be in this direction, and we write A cross B as A into B, magnitude of A into magnitude of B into sine of angle between them, and this means this we can consider it as z-axis or any if it is the direction which is perpendicular to A and perpendicular to B and perpendicular to the plane containing AB, let it be n cap. So that's the formula we have. And if we talk about the geometrical meaning of this formula, then this AB sine theta, we discussed it, that complete this this is a parallelogram, and what is the height, this height, this is B, and this perpendicular, so and this angle is theta, so perpendicular is equals to hypotenuse sine theta, so this height is B sine theta, right? This height is B sine theta. So this is A is your base, so this is your base, and this is your height. So base into height, that is the area of parallelogram. So if you take the magnitude of A cross B, so magnitude, not consider this, magnitude of A cross B is nothing but the area of parallelogram, right? So what will the area of triangle? So area of triangle is half of the area of parallelogram. So area of triangle, of course you are dividing this parallelogram in two equal parts, right? Two triangles. So this was your parallelogram, this vector A, this vector B. So you will divide this in two parts. So the area of this figure will of course be half into area of this parallelogram, area of this parallelogram. So that is the area of a triangle. Okay, so this was one way of doing it. Another way, you can simply draw a triangle. So this is A and this is B, okay, and this angle theta. So now complete this triangle, that's the triangle, and now what will be this height? This height is the same, B sine theta. So this is B sine theta. Now what is A cross B? What is the magnitude of A cross B? We have written it over here, AB sine theta. So that's the magnitude only. And so what is AB sine theta? So this is A is the base, this length, and this is the height. So that's equals to, we can, but we need half also, half into base into height, so we can multiply and divide it with 1 by 2, and this is A is the base, right, base of the triangle, multiply this B sine theta is the height of the triangle. Okay, so base of the triangle into height of the triangle. Okay, so that comes out to be, so that's the area of triangle. So twice of the area of triangle. Okay, so A cross B is area of the parallelogram made by these two vectors, and if you are considering the triangle only, so this is the triangle only, so obviously it's half of the parallelogram, this area. So area of triangle is equals to half of the magnitude of the cross product. Is this clear?
Yes.
Any problem, students? So now let us again revise the concept of dot and cross product. We have done it many times. So if you have two vectors, so A and B, and what is the dot product? And the angle between them is theta. So the dot product, or you can say scalar product, is AB cos theta. So this is only a number on this side. So obviously this is also a number on this side. So it's a scalar, so we get here the scalar quantity. And if we look at it, what is this? So this length is A. Okay. What length is B cos theta? So B cos theta is, this is B, this length is B cos theta, and this height is B sin theta. So we are considering only B cos theta. So this is your length A, and you are multiplying this length with this length, that is B cos theta. So multiplying these two lengths, you get the scalar product. So that's the interpretation of this. Now, in scalar products, when can the scalar product be zero? So scalar product can only be zero if either, so these are the three numbers I am multiplying, 1, 2 and 3. So when can it be zero? So it can only be zero when either A is 0 or B is 0 or cos theta is 0, or B is equals to 0 or cos theta is equals to 0. It means, or cos theta is 0, when is cos theta 0? Cos theta is 0 when it is 90, so theta is equals to 90 degree. So when the theta is 90 degree, then this dot product is 0. Like we have F dot S, so work done, this scalar quantity, that's a dot product. So if the angle is 0, so if theta is 0, then F and S will be along the same line and we get the maximum product. So theta is equals to 0, work done is equals to F into S. So that's the maximum that we get. Both are along the same line. So in dot products, we get the maximum when theta is equals to 0, and we get the minimum or 0 means when the theta is 90 degree. Now if we look at the concept of cross product, okay, and what are the formulas that we have? So A dot B I have written as AB cos theta, and in terms of, so this is in terms of magnitude, okay, in terms of magnitude, and in terms of coordinates, so coordinates, x coordinates, y coordinates is given to you, so then how will you write it? So A1 is the A1 B1 x coordinates, and then A1 a2 b2 and plus a3 b3. If a is written as if here a is written as vector is written as a1 I cap plus a2 j cap plus a3 k cap, and b is written as b1 I cap plus b2 j cap plus b3 k cap. Okay, then we write it like this. Okay, now for the cross product a cross b, it's a vector product, so that's a scalar product, it's a vector product, and that's equals to a magnitude. In terms of magnitude, if I write ab sine theta, so magnitude of a into magnitude of b into sine of angle between them, and then so a cross b is a vector. What is the direction of this vector? That is n cap, that is perpendicular to the plane containing vector a and vector b. And how will you write it in terms of coordinates? So a cross b, we write it in determinant form. We call it determinant form. So I j k and a1 and then a2 and then a3 and then b1 b2 b3. So that's how we write the cross product. And then I told you how to write it. We can further write it as, if we are writing the I coordinates, then hide this I coordinate and a2 b3 and then minus a3 b2. So this minus this. Okay, now for the y coordinate of this product plus, see, as we are moving, I told you that in cross product we need to move in the circle. So this I cap, this j cap, and this is k cap. Okay, so you are finding I, so start from j to k, means coordinate of j to k. Okay, this is where you need to start with. But now for j, where you are going to start with? For j, you are writing it j, you need to start from k. Is this clear? So start from k. So a3 b1. Okay, minus, now the other way, so starting from k, so you are hiding j. When you are writing for j, you are hiding j. Okay, so start from k, so a3 b1 and then a1 b3. So student, this is what you need to remember. And now then for the k coordinates, so it's a3 b1 minus a1 b3, and then for the k coordinates, so where you are going to start with? You are going to start, so I to j. So if you are considering for k, so hide the k and start from I to j. So I to j means a1 to b2. So a1 b2 minus a2 b1. So students, that's because you know that this j is actually k. So k cross I is j. Okay, k cross I is j, and this so what, this I, we started with I, like I cross is what? J cross k. So j cross k is I, and this sequence, and then k cap is what? I cross j. So I'm writing it other way around. We write it like I cross j is equals to I cap cross j cap is equals to k cap, and okay, got it? And here the next thing is that A dot B is equals to B dot A. But here A cross B is equals to minus B cross A. Why? Because if this is your vector A and this is your vector B, so here A cross B means you are putting your right hand on A and moving it towards B, so your thumb will point upward. Okay, so that's n cap direction. Now B cross A, so this was A cross B. Now B cross A means this is your A and this is your B. So B cross A means you are moving your fingers, you are putting your fingers on B and moving them towards A. Okay, so that is A cross, that is B cross A. So you need to put your fingers over here of the right hand and move them towards A, so your thumb will point downwards. So that's negative n cap direction. So this positive n cap, this negative n cap, and that is why we have this. Okay, so and distributive law is same for both of them. Means if you want to multiply A dot B plus C, then it will be A dot B plus A dot C. There is no issue with it. Okay, but here also there is no problem, no issues. So if you want to write A cross B plus C, that can be written as A cross B plus A cross C. So don't change the sequence. Any problem?
No. So
the important thing is that we need to practice the questions based on it, and if you would like to practice, so we have, so 2 questions are even sufficient to find the determinant. So one is example 7.4, which is given to us, and another is you want to practice, you can practice even example 7.5. So 7.5 is also the question of cross product, where tau is equals to R cross F. 7.4, we have 2 arbitrary vectors, so vector A and B. So that's the difference. So here instead of A I have R, and instead of B I have F. So just for practice you can do the practice of this determinant, okay, with these 2 examples. Now there is one more question, which is exercise question 7.5. Let us do that one also. I hope you have noted it down, or are you still noting it down? Shall I move forward or shall I wait? Yes?
Done, sir.
Okay. Thank you. Now, let us do exercise question 7.5. So we have a parallelepiped. So see, we have a cuboid. You are all aware of cuboid. This is a cuboid. So means we have these angles as 90 degree, right? But in parallelepiped, these angles See, cuboid is also a kind of parallelepiped. So here we have actually parallelogram. Instead of rectangle, we have the parallelogram. Okay, that's the only difference. So you can draw it like this, and so this parallel to this, and so like this you can draw it. Okay, so something like this. If you need more better figure, then let me find you. So parallelepiped is a solid body. You can write if you want to write. And which each face is a parallelogram. So what is parallelepiped? It's a solid body of which each face is a parallelogram. So we have 6 parallelograms, the faces. So we have 6 rectangles as faces in cuboid. So here instead of rectangles we have this. So here we have our parallelepiped. Okay. Now, what is the volume of parallelepiped? So this is what our question is, that show that A dot B cross C is equal in magnitude. Like earlier question, the magnitude of A cross B was half of the area of the triangle, but now the question is that it is equal in magnitude to this. Okay, so students, this is the parallelepiped, and we consider these 3 vectors. This is the base of parallelepiped, okay, and this is vector B, this is vector C. Okay, so this is your vector B, and that's your this is your vector C, and this is your vector A. Okay, so these are the 3 vectors that you have. So we consider a parallelepiped having the 3 known coplanar vectors. So known coplanar vectors, these 3 vectors, means all 3 of them doesn't lie on the same plane. And where their edges are meeting, so they are meeting at O. So let us consider this point as O. Okay, so where will be your B cross C? So if this is your base, so obviously perpendicular to this, this is your B cross C. This is the cross product, and the length of this is that is equal to, the length is equal to the area of this base, right? So we can even give them the names like OB, this is OA, this vertex, and this vertex as C. Okay, now B cross C, it's a vector which is perpendicular to the plane of B cross C, and the angle between B and C is theta with the angle. So let here, instead of this angle theta, let me consider, and even this alpha I don't need, I need this angle which is between A and B cross C. So I need this angle. So this angle is actually theta. So this angle is theta, this one. Okay, so this angle, this is your B cross C, and that's your vector A. This angle I am considering as theta. Okay, this is O. This is maybe of larger length, doesn't matter. Okay, I'm not drawing it to the scale, but I'm just telling you that theta is the angle. So what will be the what is the height of the parallelepiped? This height. Okay, so this height, if I'm taking this as angle theta, so these are the parallel lines, so this angle will also be theta. Okay, so this angle is also, so this is theta, so the height will be A. So height of the parallelepiped is equals to A, so magnitude of A cos theta, so it's A cos theta. Okay, now let us find A dot B cross C. So what is A dot B cross C? So that's equals to, so how do we write the dot product? So magnitude of A into magnitude of B, so here your B is B cross C, okay, and into cosine of angle between them, and that's equals to, see what is base, what is height? Height is A cos theta. So let us write A cos theta together. So and what is this B cross C? That is the area of a base. So this into, I can write it as A cos theta, right? So this B cross C is the area of base, so that's the base area of parallelepiped, into, that's the height of the parallelepiped. So base into height is volume. So that's the volume of the parallelepiped. So the volume of parallelepiped is so here it is O, okay. So parallelepiped, PARALLELOPIPED. Note it down.
सर जो आपने हाइट ली है पैरेललोपिपेड की वो a cos theta, but theta is the angle between b cross c and a vector.
See, in physics, in science, you need some imagination also, because in other figures also, it is when we are dealing with 3D figures, it's very difficult to draw the 3D figures, so you need somewhat of imagination. Okay, let us discuss it, how this height is a cos theta. See, this is the base of parallelepiped, right? So what will be the height? Height is the distance between these two planes, this plane and this plane. Yes, these opposite faces of the parallelepiped. That will be the height if you are considering this as base, right? If you are considering this as base, right, this one, right? So the height will be the distance between these two planes. Yes, agreed? Yes, the perpendicular distance between these two planes, that's your height. Do you agree with it?
Yes, sir.
Okay, and here also A cross B is also perpendicular to this base. So both the sides are both these are perpendicular to the base. Agreed?
Yes, sir.
A cross B, this is your B, this is your A. So A cross B vector is perpendicular to the plane containing A and B vector. Okay, so this height and this A cross B, are they parallel lines? Yes. This is also height, this is also height. Agreed?
Yes, sir.
So these two are parallel lines, this and this. Yes.
Yes, sir.
And this angle is theta. Okay, and these two are parallel lines, right? So this will also be theta. Yes, this angle is theta and this angle will also be theta. Agreed? Yes.
Sir.
Yes or no?
Sir, I am saying yes, sir.
Yes. Okay, thank you. So this is your height, this is your A cross B. So this angle is theta, and these two are parallel lines, so alternate angles theta. So this is now hypotenuse, right? This is hypotenuse, and that is your length A. So that's your length A. Okay, so what is this? H will be equals to, so that's the base, means adjacent side. So the adjacent side upon hypotenuse is what? Cos theta. So adjacent side is equals to hypotenuse cos theta. So your adjacent side is H, and what is hypotenuse is A. So H is equals to A cos theta. Agreed?
Yes, sir.
Okay. That's a very good question you have asked. So you can consider this angle as theta here. Okay. So this H is equals to A cos theta.